All right, let's jump in here and talk about the tangent of alpha plus or minus an angle. Quick review though, little aside, quick review. Oh, hang on. Sorry. All right, quick aside, and that is the sine of alpha plus or minus an angle equals sine alpha cosine beta plus or minus cosine alpha sine beta. And the cosine of alpha plus or minus beta is cosine cosine. So cosine alpha cosine beta, but then this is minus plus, remember, minus plus sine sine. So sine alpha sine beta. So let's go through the steps. And we developed one of those in a lot of detail. We spent a lot of time on that last week. But the goal today is how can we do the tangent of alpha plus or minus an angle. So let's start with the tangent of just the angle of alpha plus beta. Quick review, we know that the tangent is sine over cosine. So let's go through the steps. Tangent of alpha plus beta would be the sine of alpha plus beta divided by the cosine of alpha plus beta. No surprise there. But now we're going to have to go through a little bit of work and write this out. So this is sine alpha cosine beta plus cosine alpha sine beta. In the denominator, cosine alpha cosine beta minus sine alpha sine beta. And on this step, we're going to divide everything by cosine alpha cosine beta. So we're going to divide by cosine alpha cosine beta. We're going to divide every term by that. If you allow me to, I would like not to write it down. I'd like to do some of it in our head a little bit. Unless you want me to write it all down, we could do that. But so when I say everything, we're going to have to do this one, then we're going to have to do this one, then we're going to have to divide this one by it, and then we're going to have to divide this one by it. So every term, because you're going to divide the top by cosine alpha cosine beta, and if you divide the top, you got to divide both of those by cosine alpha cosine beta. So when I do the first one, let's try to do this without writing it down. If I do this one right here, if I divide by cosine alpha cosine beta, what do I get? Sine alpha over cosine alpha. What's another name for sine alpha over cosine alpha? Tangent. So that one's going to be the tangent of alpha plus, what do you get when you divide this one? By cosine alpha cosine beta. You get sine beta over cosine beta, which is the tangent of beta, divided by, this one is probably the easiest of all of them. What do you get if you divide that one by cosine alpha cosine beta? You guys are going to eat, you know what? You got to share with everybody in the room. So, perfect. Start sharing. I'll keep teaching. You guys can share while everyone can eat rather than just two of you. What do you get when you divide cosine alpha cosine beta? I'm actually serious. Either throw your stuff away or share with everybody. Cosine alpha cosine beta is 1 minus sine alpha over cosine alpha is tangent alpha. Sine beta over cosine beta is tangent beta. And that is our formula. The tangent of alpha plus beta is right here. Now, we wanted to do a second part. And the second part was tangent alpha minus beta. Just like we did with the other ones, let's just do a quick review on what happens if you do the tangent of the opposite of beta. I'll use beta because that's where it's going to go. The tangent of the opposite of beta So you're looking at first quadrant and fourth quadrant. It's just like the sine, so it's going to be the opposite of the tangent of beta. So if I wanted to talk about the tangent of alpha minus beta, I would say tangent of alpha plus the opposite of beta. So if I use those rules, just like we did with the sine, we're going to end up with tangent alpha minus tangent beta divided by 1 plus tangent alpha tangent beta. So what we have right here is a formula for the tangent of alpha minus beta. And of course, just like we did with the sines, we like to combine those two. And if I combine both of those, I would write something like this. Tangent of alpha plus or minus beta is tangent alpha plus or minus tangent beta. In the denominator, this would be 1 minus plus tangent alpha tangent beta. So this, I guess, is the summary, just like we had up here and here. Do I need to talk about this more, or are we okay with that? We're looking at first quadrant. Maybe I'm really looking at people that were in DC, because I think we covered it last week pretty well. But when we do the tangent of an opposite of an angle, so if you're looking at something like, you're looking at an angle here and an angle here. So if this was just like 20 degrees and then you're doing the negative 20 degrees, when we talked about the cosine of that angle, we said that they're going to be the same because it deals with the axis and the x value is the same. But when we look at the y values are going to be opposites. So the sine of 20, or let's use 30 because that's an easy one, the sine of 30 is a half, the sine of negative 30 would be negative 1/2. So in general, we said something like the sine of the opposite of theta is negative opposite the sine of theta. We said the cosine of negative theta is the cosine of theta. So I think it follows then, if we talk about the tangent of the opposite of an angle, we get the opposite of the tangent. Okay? Got to share everything, not just the goldfish. So whatever you got there, you got to share too. Okay, pass them around. I know Brady will eat them. He's a hungry, growing boy back there. Okay, so let's talk about this formula. Did he say no?
Sure.
No, I figured. Okay. Let's apply that. Let's apply this right here to a problem like this. Let's do the first one, or the top one. Let's look at this. Just like what you did when you had the sine and cosine, I hope that you recognize this. And you would say, well, what we're talking about then, right there, is the tangent of, that looks like 4 pi over 3, and that would be a minus pi over 12. Because this is a minus, so then this one's going to be a minus. And we see that it fits the formula. Tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta. It fits the formula. So now we add our fraction right here. What do we get when we add that? 12s, so this is 16 pi over 12 times 4. 16 pi over 12 minus 1 pi over 12 is 15 pi over 12. And what does 15 pi over 12 reduce to? Take a 3 out of both of them. That's a tangent of taking a 3 out. 5 pi. Oh. Tangent of 5 pi over 4. That's a nice one. What does 5 pi over 4 reference to? 5 pi over 4 references to 1 pi over 4. It references to an angle in quadrant 1. So you think about how far it is from the x-axis. 5 pi over 4, right, is like this. So the angle that we're talking about is this angle right here. We say, what does it reference to? Because we know vertical angles, that one's the same. It references to pi over 4. You're in quadrant 3, so the tangent is positive. So in quadrant 1, the tangent is positive. In quadrant 3, it's positive, so obviously positive in quadrant 1, and it references to pi over 4, and the tangent to pi over 4 is 1. So you don't need to plug that into your calculator. You get 5 pi over 4. That's a special one we should know, and we say that it's 1. If it would have been in quadrant 2 or quadrant 4 and it references to pi over 4, like 3 pi over 4 or 7 pi over 4, your answer would be negative 1. Okay. How about this? I tell you that the tangent of the angle alpha is a third. I tell you that the tangent of beta is a half. We're supposed to evaluate the tangent of alpha plus beta. Now, what I would like you to realize is I don't find out what alpha and beta are. I do know that alpha is the inverse tangent of a third. We do not need to find out what the angle is. The formula says that this is the tangent of alpha plus the tangent of beta. Don't really need parentheses around that. 1 minus the tangent of alpha, the tangent of beta. So now all we need to do is replace. What is the tangent of alpha? I don't need the angle alpha. I just need to know the tangent of the angle alpha. And the tangent of the angle is a third. So I would have 1/3 plus 1/2 divided by 1 minus a third times a half. So in the numerator, when I add those two, a third and a half, that's 2/6 and 3/6, so that's 5/6. In the denominator, I have 1 minus 1/6. 1 minus 1/6 is 5/6. So the answer is 1. That does tell me, by the way, something about adding these two angles together. What do you get if you add those two angles together? We don't know what they are, but if I add them together, what will I get? 45 degrees. Because the tangent of adding them together is 1. Or it could be something that would be in quadrant 3 that references to 45, which is 225, or 5 pi over 4. Okay? Just one more thing we have to talk about, and that is, how can we find the angle between those? I'm not going to do any more examples of doing the tangent of alpha plus or minus beta. If you've done enough with the sines and the cosines, the tangent just falls in. So today's really a lot easier day than what we did with the sine of alpha plus or minus beta and the cosine of alpha plus or minus beta. But the second part of today, we need to spend about 5 minutes talking about how we can find the angle between two lines. So I've just drawn two lines. I've called one angle, or one line has a slope of m. I've drawn another line that has a slope of m sub 2, m sub 1 and m sub 2. Recall, we did cover this a while back, but if we wanted to talk about the slope of m1, we said that if you did the tangent of alpha, you would get m1. How the angle, what the angle is when it meets the x-axis. You guys remember that? The angle, the slope is equal to the tangent of the angle of how it meets the x-axis. So that means, what about m2? The slope of the line, so this slope is m2. What would that equal? My picture may be a little bit hard to read, but I hope to identify that as beta. So the tangent of beta, the tangent of that angle, how it meets the x-axis, will give you the other slope. And we talked a little bit about this. We said if the angle's acute, which beta is acute, so it has a positive slope. The angle's acute. If you do the tangent of the angle, it would be positive. The tangent of an acute angle between 0 and 90 is positive. If you do an obtuse angle, so the slope is negative, like m1, the angle is obtuse, bigger than 90, smaller than 180. And when you do the tangent of an angle bigger than 90, smaller than 180, it is negative. So it all kind of fits into place. Now, think back to your geometry class. What is the relationship between alpha, beta, and theta? What's the relationship between those three angles? You might have called something like this: the sum of an exterior angle is equal to the exterior angle of a triangle is equal to the sum of the two remote interior angles of a triangle. I don't know if you learned it that way or not. Something to that effect, though. An exterior angle is equal to the sum of the two remote interior angles. So therefore, when I look at a triangle like this, I know that theta plus beta would have to equal alpha. Does that ring a bell to everybody? So therefore, I'm trying to find the angle between these two lines. The angle between these two lines, according to my picture, is theta. So if I solve this for theta, I would get alpha minus beta. And what happens if I do the tangent of theta? I get the angle between those two lines. The tangent of theta, which is the tangent of alpha minus beta, will be the tangent of alpha minus the tangent of beta all over 1 plus the tangent of alpha, tangent of beta. So if you have two lines, we can always find the angle that they meet. Now I do hope that some of you are thinking a little bit, when two lines meet, let's try to exaggerate it a little bit more than what we have up there. I hope some of you are wondering, maybe we should exaggerate it even more. Oh my goodness. I didn't exaggerate that more. Well, kind of did. Are we talking about this angle? Or are we talking about this angle? And how are those two angles related? They're going to be supplementary. They're going to add up to 180. So either one you find, you'll automatically be able to find the other one. And when you use this formula, depending on which you pick for alpha and which you pick for beta, you're either going to get a positive answer for tangent or a negative answer for the tangent. When you do the inverse tangent, so either you're going to get 20 degrees or you're going to get 160 degrees. You with me on that? So you can decide which one you want when you're done. You're going to get an answer, but then you'll have to decide maybe what is being asked for, because it does present two different angles. So here I have two lines. Y, the red one is y equals 3x plus 1. And the purple one is 5 minus 2x. So the question is, at what angle does the red line and the purple line meet? So you know the slope of the red line from algebra class. The slope of the red line is 3. You know the slope of the purple line is -2. So the question is, what angle do they meet? You might be wondering, am I talking about this angle or am I talking about that angle? And it won't matter. It won't matter. So let's do both of them. The tangent of theta, if we say M1 is red, you would have 3 minus a -2 all over 1 plus 3 times a -2. So when we do the math, we have 5 in the numerator, we have 1 minus 1 plus a -6, 1 minus 6, we get -5 on the bottom. So the tangent of theta, if we do it this way, is a -1. So I know that my angle, if you do the inverse tangent of -1, what does your calculator say? Let's go with degrees, and we'll talk about radians as well, but let's go with degrees. Do we know that one off the top of our head without using our calculator? I want you to use your calculator, but it's quicker without. Well, we don't, remember, when you do the inverse tangent, you're going to get an answer that's either in quadrant 1 or quadrant 2. Well, your calculator might say -40, I suppose. But we want to give the answer in terms of either an acute angle or an obtuse angle. So if you get, does your calculator say -45? So what angle are we going to say? 135 degrees. And if I say 135 degrees, of course, I'm talking about this one right here. Then what does this one have to be? Of course, it has to equal 45, right? Because they have to add up to 180. 180 minus 135 is 100, or is 45. Let me just show what I mean by that, though, if you went the other order. So we went this way. If I would have said theta, and I'm talking now about this one, and you don't really know which one you're getting. And my point is it doesn't matter. That's what I want to show right here. If instead then you would say negative 2 minus 3 all over 1 plus negative 2 times positive 3. We would get negative 5 on the top, we would get negative 5 on the bottom, which is 1. Tangent of what angle is 1? 45 degrees. So you can decide, do you want the obtuse angle or do you want the acute angle when two lines meet? They will always be supplementary. Okay? That's pretty simple, I hope, that this formula is pretty simple to use. And I've only presented one formula. Two, I suppose. But this is all I presented. The tangent of alpha plus or minus beta, tangent alpha plus or minus tangent beta, over 1 minus plus tangent alpha tangent beta. I'm going to give you lots of time to get into this a little bit, so before I can get some questions answered if needed. This one, compared to the last assignment and compared to the last topic, this is much easier. But we had a lot of time last week to kind of work on this. Remember, there are only 4 sections in this chapter. And this is number 2. And how did I rank the test that you're going to take on chapter 10 on a scale of 1 to 10? 9. About a 9, where 10 means pretty hard, right? So it's going to be a 9. The last test you took, I do have those. People that took them late, I have those corrected. Last test was probably about a 2, because I think our lowest score was probably about an 80, 81, something like that. So let's make sure we stay on top of it. This assignment right here, though, should go pretty smooth. But if questions, please ask. Please get your questions answered. I also have updated the week, too. I'll print it off, put it there. If you go online, you can find it. I apologize. Did anybody watch the podcast from last week that were gone? What happened during that podcast? Why didn't you get to see the assignment at the end of the hour? It was a fire drill. And some of our kids might have perished if it had been a real fire because I didn't let them out right away. But we all survived. And there was no lawsuit. You may.